All right, you guys, today we are looking at special right triangles. Well, we're pretty familiar with right triangles. The question is, why are we calling these special right triangles? So try and understand, with right triangles, we had this cool theorem called the Pythagorean theorem. A squared plus B squared equals C squared. But in order to use it, well, first we needed a right triangle, but we also needed 2 out of the 3 sides. If we have 2 sides, we can always solve for the third. Pythagorean theorem helps out a bunch. The reason these triangles, and there's only 2 of them, the reason they are special is I only need to know one of the sides, and I can find the other 2. And that certainly is a bit more special than the Pythagorean theorem. All right, so there's only 2 triangles. One of them is called a 45, 45, 90 triangle, and the other one is a 30, 60, 90 triangle. Those crazy numbers refer to the degree measures inside each triangle. We're going to look at this one first, a 45, 45, 90 triangle. Try and realize this triangle is the result of cutting a square in half across the diagonal, all right? So since 45 degrees, since those are the same, this is actually an isosceles triangle. So it makes sense that whatever the measure of this side is, I already know that this side's got to be the exact same. Now I'm going to show a little mathematical proof here that if I know these 2 sides, I actually know the measure of the third side. In order to do that, I'm going to do a quick little Pythagorean theorem, walk through here, because I know one of the sides, A and B, are the same. Well, the question is, does that mean I know what C squared is? Well, I've got an X squared. I got another one. That's 2X squared. And if I want to know what C is, I would need to eventually square root both sides. This would get me down to C. But if we're looking at this situation, the square root of 2, I don't know what the square root of 2 is. You probably don't know what it is either. But I do know the square root of X squared allows me to bring an X out here. That means that the third side has to be whatever that number that I already knew was times the square root of 2. All right, so this generates what we call, both of these are really what I would call the rules. All right, so if I know those 2 sides, the third side is whatever that number is times the square root of 2. Okay, so this is a rule for every 45, 45, 90 triangle. So this produces a bunch of different types of possible problems, okay? And I even have a procedure here, all right? And make sure, if we're going to say, here's some examples here. We'll look at this first example up here, all right? Part of the procedure is make sure you actually have a special right triangle. Now, I know that's 45, that's 90. Would that last angle be 45 degrees? Yeah, the triangle sum theorem does say, all right, this is a 45, 45, 90 triangle. So anytime you're doing this, your first procedure step is make sure, do I have a special right triangle? All right, on this problem, I do. All right, so we can try and apply this rule over here. So step 2 in the procedure, these are my recommendations, would be to label these sides according to the rule. Which means I need to be able to pick up these 3 items and put them down onto this example. All right, so I know the 2 sides that are the same, I would call those X. And the third side is just going to be whatever X is times the square root of 2. So I've labeled all 3 sides based on this rule down here. All right. So on one of the sides, I should have a matchup. I should have a number matched to a part of the rule. I'm just going to make that an equation. All right. Wherever I end up with an equation, I want to solve for x. Now, if you'll see on this very first example, if I have this equation, x equals 7, and I've just asked you to solve for it, that's why this problem we're starting off with is not too bad, because it's already solved. X is 7. If I know what x is, then I'm just down to my final step. I know what x is. All I got to do is plug the value of x in everywhere else. It's a simple 4-step procedure. So if I know x is 7, my side over here is also going to be 7. Now here, if x is 7, again, I told you to plug it in. So if I was on my whiteboard here in the classroom, I would erase x and put in 7. Since I don't have a whiteboard, I'm going to just write it like this. Here, there's my 2 answers. I had 2 question marks. Okay? So again, the procedure. Make sure you have a special right triangle. Label the sides according to the rule. Find out what x is, and go plug it in. So here we go. Let's try it again on example 2 here. I got 90 degrees. It is isosceles, which means these angles would be the same. This is a 45, 45, 90 triangle. So step 1, I'm good to go. Label the sides. The 2 sides that are the same, I would call those x. And this would be where I have my matchup. So 8 square root of 2 is my x times the square root of 2 side. So if you don't see the solution, again, I would take that equation, 8 square root of 2 equals x times the square root of 2. And the way I would solve, if I want to get x by itself, that's multiplication, I would just divide both sides by the item I'm trying to get rid of, which is the square root of 2. Now, if the square root of 2 is canceled out over here, that's the same thing that's going to happen here. That means x has got to be 8. Once I know what x is, I go plug it in. This side, 8. This side, 8. Procedure will work every time. Now, let's go look at the difficult process here, and we're going to have to learn a new skill. But let's take a look at it. 45, 45, 90, it is a right triangle. This would be x, x, and here's my matchup. This is x times the square root of 2. So here's where my matchup is. I need to solve for x. Well, we've done this before. I just need to divide both sides by the square root of 2. Here, those radicals cancel out. But here, I cannot divide the square root of 2 into 10. And actually, this is a big problem because the square root of 2 is what's called irrational. It cannot be discussed as a fraction. Well, something that can't be discussed as a fraction, trying to divide something into fractional amounts. This is a big math no-no. We're not allowed to leave answers in this form. So you need to learn a new skill, all right? This is called rationalizing a denominator. A denominator is the bottom part of the fraction. We're going to try and rationalize this because we're not allowed to leave a radical like that. So we're going to take that fraction, 10, divided by the square root of 2. The way you rationalize a denominator like this, I'm going to multiply by a very clever version of the number 1. If I multiply by 1, nothing changes, but I'm going to multiply the top and the bottom of the fraction by that radical I'm trying to get rid of. So what we end up in the top, 10 times the square root of 2. I can't combine those, but I can put them next to each other. That's just 10 times the square root of 2. Now the square root of 2 times the square root of 2, I can do that. That's the square root of 2 times 2, which is 4. Well, hopefully most of us know what the square root of 4 is. I can't do anything to the top, but the square root of 4 is 2. Look at that. I got rid of the radical in the denominator of the fraction. The only question is, will this reduce? I cannot divide a 2 into that radical, but I can divide the 2 into the 10. 2 into 10 leaves me with 5, and I still have that radical, 5 square root of 2. So all of that was to find out x. Since I know what x is, now all I got to do is plug it in. 5 square root of 2 and 5 square root of 2. All right, so this is by far the more difficult version. There is certainly some easy, real easy versions. This one wasn't too bad, but then we've got some work to do down here. That is just 3 quick examples of 45, 45, 90 triangles. Now realize there's another kind of triangle here. All right, this is called a 30, 60, 90 triangle. So this happens to actually be half of an equilateral triangle. All right, the smallest side down here, we're going to call x. Since this is half of an equilateral triangle, then this side would actually be twice its size. And I could use the Pythagorean theorem to prove again, this third side will be x times the square root of 3. So this rule is different. The procedure is not different. Okay? So here we go. We're going to try and take a look. I'll try and see if I can keep this rule up here close, because remember, we're going to try and take these values and bring them over to our problem here. All right. So this happens to be a 30, 60. If that's 90 degrees, this will be 90 degrees. I do have a special right triangle. Now, here's where you got to be really careful. Try and realize, got to get these labels right. If we get them wrong, we will get the problem wrong by definition. The smallest side will always be across from the smallest angle. All right. So smallest angle, smallest side, this has got to be my x side. The longest side is across from the longest angle. That's 2x. And the third side is x times the square root of 3. You have to get those labels in the right place. If you cannot get them on the right place, you will get the wrong answer. So step 3 says solve for x. Well, this was the easy problem. I already know what x is. X is 6. All I got to do is go plug it in. If I plug 6 in here, 2 times 6 is 12. If I plug 6 in here, 6 times the square root of 3, I can't combine those. It's just 6 times the square root of 3. Okay, so we'll try a slightly more difficult version. Again, smallest side. This is a 30, 60, 90 triangle. Smallest side. It's got to be here. That's x. Here's my longest side. That's where I have my matchup. That's going to create the equation. And my third side is x times the square root of 3. Going through the procedure, same way every time. All I got to do is take this equation and take this elaborate algebra problem, solve for x. Well, I can do that by dividing both sides by 2. Turns out x is 9. If I know what x is, you just go plug it in. 9. And if I were on my whiteboard, I'd erase the x, put in 9, and I would have 9 times the square root of 3. Easy peasy lemon squeezy. Now let's do the difficult version. All right. Now here I'm making it, before I've just been putting question marks, which is really nice of me because then we don't get very confused. Here I started putting variables. Now be careful in the problem. If they put variables, that has this x has nothing to do with this rule that we're using over here. So you got to be very careful. All right. Turns out this is a 30, 60, 90 triangle. If I want to label the sides, turns out the smallest side is over here. This is what I want to think of as my x from the rule that we designed earlier. These are just question marks. Try not to let them confuse you, because this is the longest side. This should be 2x. And here's where my matchup is with x times the square root of 3. Here's the equation I need to be solving. If 9 equals x times the square root of 3, I just want to divide both sides by the square root of 3. Here's my issue again. I got to use my new skill. X equals 9 divided by the square root of 3. I cannot leave this irrational value in the bottom of the fraction. So I need to rationalize the denominator. If you remember the procedure, we're going to multiply the top and the bottom by the radical we're trying to get rid of. In the top, you have 9 times the square root of 3. In the bottom, the square root of 3 times the square root of 3 is the square root of 3 times 3, which is 9. The reason we do that is because this is always going to be a perfect square. The square root of 9 is 3. The radical is gone. In the top, we still have 9 times the square root of 3. Then you just got to see, will this reduce? It won't reduce every time, but here, the 3 can't go into the square root of 3, but the 3 can go into the 9. That leaves me with 3 into 9. Leaves me with 3, and then I still have the square root of 3. Now remember, that's what x is. X is 3 times the square root of 3. I still need to come back here and plug it in, because I still want to know what their x and their y equals. All right? So if I want to find out what their x is and their y is, I got to plug it in. I got to take 3 square root of 3 and plug it in right there. So instead of 2 times x, I got to plug in 3 square root of 3. Now, what are we allowed to multiply here? This isn't distribution. The only thing I can multiply is the 2 times the 3, which is 6. And then I still have the square root of 3. All right. And this side, which is y, this one's a little bit easier, is just what 3 square root of 3 is. So make sure this is, this can be a little bit confusing, all right? Just a quick example just to remind you what you're allowed to do. If I had 2 times the square root of 3 and I multiplied that by 4 square root of 5, make sure you realize what you're allowed to multiply. You're allowed to multiply the oranges and the apples. All right, I can't put this 2 inside this radical, but I can multiply 2 times 4, which would be 8. All right, and the square root of 3 times the square root of 5 is the same thing as the square root of 3 times 5, which is 8 squared of 15. So be careful. These are the things that you're allowed to do. Make sure you remember your new skill here, rationalizing a denominator. And I hope you really wrote down, it's going to be highly valuable to have easy access to these rules. And if I were you, I would know how to apply the procedure that I came up with here that makes things a little bit simple and just gives you an attack plan that works every single day of the week, twice on Sunday. Good luck.